In previous lessons, we've looked at how to add and subtract numbers using symbols, diagrams, and we've learned the rules for adding and subtracting integers. And today we're going to learn another method, which is how to show addition and subtraction on a number line. And so in our first example, it says, suppose that you received $10 from your grandmother for your birthday. You spent $4 on snacks. Using addition, how would you write a number sentence to represent this problem? Okay, well, let's think about what's happening here. If we receive $10, that's going to be represented by a positive 10. And if you spend $4, that's going to be represented by a negative 4. And since they want us to use addition here, I'm going to do the addition problem, 10 plus negative 4. Okay, and using our rules for addition, we know that since these numbers have different signs, I'm going to subtract their absolute values. The absolute value of 10 is 10. The absolute value of negative 4 is 4. 10 minus 4 is 6. And I'm going to keep the sign of the number with the greater absolute value, which happens to be the positive number in this case. So 10 plus negative 4 equals 6 would be our number sentence. Question A says, how would you model your equation on a number line to show the answer? And this is what the main idea is here today, how we can show addition using our number line. Okay, so since my addition problem used two different numbers, I'm going to draw two different arrows on this number line. My first number line is always going to start at 0, and it's going to go to the first number in the problem, which happens to be positive 10. So I'm going to draw an arrow starting at 0, and I'm going to draw it 10 units to the right. So let's go ahead and draw that arrow on our number line. Okay, and that's the number positive 10. You can label it as a positive 10 if you would like. Our second arrow is going to start where the first arrow ended. In this case, it ended at 10. So our second arrow is going to start at 10. And since I'm adding a negative 4, that means I'm going to have to move to the left 4 units from 10. So if I start at 10 and I move 4 units to the left, there's my arrow. Okay, and again, this arrow represents the integer negative 4 since it's moving to the left 4 units. And I can see where it stopped right here. It stopped at 6. So 10 plus negative 4, the sum is equal to 6. So in example 2, we're going to complete the steps to finding the sum of negative 2 plus 3 by filling in the blanks to these questions here. Okay, we're going to model the number sentence by using straight arrows, which we call vectors, on this number line. So we're going to repeat the process from example 1. This time, though, it's for the question negative 2 plus 3. So the first thing that we always do is place the tail of our arrow on 0. Our first arrow is always going to begin at 0. And since we have negative 2, we're going to draw the arrow 2 units to the left of 0. And so if we do that, here's our number line. I'm going to go 2 units to the left of 0, which means I have stopped here, stop at negative 2. Okay, again, the direction of the arrow was to the left since we were counting down from 0. Okay, negative numbers are going to move us to the left, positive numbers are going to move us to the right. In step C, it says start the next arrow at the end of our first arrow. Well, our first arrow ended at negative 2, so our next arrow is going to start at negative 2. Okay, so I'll put my little dot here to start where my arrow is going to begin. And I'm going to draw the second arrow 3 units to the right since you were counting up from negative 2. Okay, we were adding a positive 3. So we're going to go 3 units to the right. So here I am at negative 2. I'm going to go to the right 3 units. 1, 2, 3 units. Okay, and I can see that we just stopped right here at positive 1. Okay, so again, our first arrow was 2 units to the left of 0. That's negative 2. Our second arrow went 3 units to the right, so this is a positive 3. And based off of where this stopped, I can see that negative 2 plus 3 is equal to positive 1. In example 3a, we're asked to repeat the process for the expression 3 plus negative 2. Okay, so again, our first arrow is always going to start at 0. And this time, since the first number in the addition problem is 3, I'm going to move to the right 3 units. So let's go ahead and draw an arrow moving to the right 3 units, stopping at 3. Our second arrow is going to start where our first arrow ended, so I'm going to just put a little dot where my next arrow is going to begin. And since I'm adding -2, that means I have to go to the left 2 units. So I'm going to go to the left 2 units, 1, 2. And there we have it. Okay, so again, my first arrow was a +3. My second arrow was a -2. And I can see based off of where this arrow ends that 3 plus -2 is equal to 1. Okay, so 3b says, what can you say about the sums of -2 plus 3 and 3 plus -2? Well, in this example, -2 plus 3 was 1. And in this example, 3 plus -2 was also 1. Does order matter when adding numbers? Why or why not? Well, again, we just saw that if we did -2 plus 3, we got 1. And if we just switched the order and did 3 plus -2, we also got 1. So we can say here that order does not matter when adding numbers. Order does not matter when adding numbers. Okay, and this is because the operation addition is a commutative operation. Okay, addition is commutative. All right, you may have heard of the commutative property before. The commutative property states that you can change the order of your addition. You're still going to get the exact same answer. In example 4, we're told that a football team gains 3 yards on first down and loses 8 yards on second down. Write a subtraction problem that represents this situation. Okay, so if we think about this in terms of our football team here, if they've gained 3 yards, that's going to be a +3. And then, since they lose 8 yards, we're going to take away 8 yards. Okay, and so there is our subtraction problem, and we're going to show that on this number line underneath. So, since my first number is a +3, again, I'm going to start at 0, and I'm going to go 3 units to the right. Okay, my second arrow is going to start where the first arrow ended, so I'll put a little dot right there. And since I'm taking away 8, I'm going to have to move to the left 8 units. So let me move to the left 8 units. 1, 2, 3, 4, 5, 6, 7, 8 units right there. And I can see that I've stopped here at -5. So 3 minus 8 is -5. And if we think about the numbers that these arrows represent, 3 units to the right, well, that was a +3. 8 units to the left is a -8. So remember, this subtraction problem can be rewritten as an addition problem. Remember that you can change a subtraction problem into an addition problem. 3 minus 8 is the same as 3 plus -8. Remember, you keep the first number the same, and then you add the opposite of the number that's being subtracted. Add the opposite of the second number. In example 5, they want us to model the subtraction problem 4 minus -6 on the number line by first changing the subtraction problem to an equivalent addition problem. Okay, so I have this subtraction problem, 4 minus -6. They would like us to rewrite it as an addition problem first. So again, the process here, you keep the first number the same. So my 4 is going to stay the same. And then I'm going to add the opposite of the number being subtracted. The number being subtracted is -6. The opposite of that number is +6. So 4 minus -6 is the same as 4 plus 6. So let's draw our first arrow. Our arrow begins at 0, and since it's a +4, we're going to move 4 units to the right, stopping at 4. There's our +4. And now our second arrow is going to start at 4. And since we're adding 6, we're going to move 6 more units to the right. And if we add 6 units to the right, we're going to stop right here at positive 10. So that arrow represents a positive 6. And both of these expressions are equal to 10. 4 minus negative 6 is 10. 4 plus 6 is also equal to 10. In example 6, they want us to plot all numbers that are 5 units from 3 on the number line below. We're going to write 2 number sentences that could be used to find each point. Okay, so we're going to be starting at 3. So I'm going to put a little dot on 3. There we are. And I want to find all numbers that are 5 units away from 3. Okay, well, I can move 5 units in either direction. Okay, I can move to the right or I could move to the left. Let's start by moving to the right. I'm going to draw an arrow 5 units to the right of 3. 1, 2, 3, 4, 5 units right there. That's a positive 5. So one addition problem that I could write, if I start at 3 and I add 5, that gets me to 8. Okay, they wanted us to plot the numbers, which means I have to put a dot on the number line where that number is located. One of the numbers is found here at positive 8. Okay, but I also said that I could have moved to the left. So if I started at 3 and I moved to the left 5 units, 1, 2, 3, 4, 5 units to the left, this time since I moved to the left, this arrow would represent a negative 5 or subtracting 5. So if I start at 3 and then I take away 5, I've ended here at negative 2. And again, they wanted us to plot the number, so I'm going to put a dot right here on the number line where negative 2 is located. Okay? Instead of drawing a subtraction problem here, I could have rewritten this as an addition problem, 3 plus negative 5, which also would get me to negative 2. Okay? And remember that this addition problem could also be the subtraction problem, 3 minus negative 5. All right? I probably wouldn't write it like this, but it is equivalent to 8 as well. Remember, to change this subtraction into this addition problem, you keep the first number, and then you add the opposite of the number that's being subtracted. In example 7, we're told that on a cold night, the temperature started at 5 degrees. Overnight, the temperature drops 8 degrees. By noon the next day, the temperature rises 12 degrees. What is the temperature at noon? We're going to show our work on the number line below. Okay, so on a cold night, the temperature starts at 5 degrees. So I'm going to draw an arrow to represent our starting temperature of 5 degrees. So I'm going to start at 0. And since it's a positive 5, I'm going to move 5 units to the right. Okay, there's our starting temperature at 5 degrees. Overnight, the temperature drops 8 degrees. So my second arrow is going to start at 5, and since the temperature is dropping, I'm going to have to move to the left 8 units. So let's go ahead and do that. 1, 2, 3, 4, 5, 6, 7, 8 units to the left. So this arrow is negative 8. Notice now the temperature is negative 3 degrees. But by noon the next day, the temperature rises 12 degrees. So we're going to draw a third arrow, which is going to start at the end of this arrow at negative 3. And since the temperature rises 12 degrees, we need to move to the right 12 units. So let's go ahead and do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units to the right. There's our arrow for positive 12. And so now I can tell that the temperature at noon, right here, would be 9 degrees. Okay, I can show that with a math problem as well. If I started at 5 degrees, and then the temperature drops 8 degrees, I can make that a minus 8. And then when my temperature rises 12 degrees, I can just add 12. Okay, well, 5 minus 8, that's the same as 5 plus negative 8, which is negative 3. And then if you add 12 and negative 3, that gives you a number 9. So the temperature is 9 degrees.